How's it going, everyone? Javier Gonzalez here again. And in today's video, we're gonna take now finally is the approach of how can we create these objects in the ES6 and 7 ECMAScript as a way to understand, well, not only how can we create objects using the class keyword, but actually how those inner mechanism works behind the scenes. So by now, I would like to make a quick recap of this course, which is taught by Will Sentence. Shout out to Will Sentence, the CEO of Codesmith, which is a software engineer, machine learning engineering residency, headquarters in California, in New York. So the idea here is that by looking at how you can create objects in JavaScript following is the object-oriented programming, now this allows us to write applications that can scale in a professional engineering environment. So why this is important? Because especially if you're going to dedicate your time and energy to this field, it is important to understand how now the machine that you're gonna use, you know how that work. Pretty much if you ride a bicycle or a motorcycle or a vehicle, it is important, at least in theory, how that work, and especially if you're gonna use that daily, and if you're going to solve someone else's clients. So the idea here is that now by looking at how the object-oriented programming plays out in JavaScript, and by looking at how can we create objects, and then how we can subclass in that, and how we can make that using the prototype change, using is the new keyword, and then what we care about in today's video, which is how can we create objects using the class and extend keyword and what it's doing behind the scenes, so we can be more precise when we need to communicate something. In this case, this object-oriented programming approach using the prototype nature of the JavaScript. So first thing first is to take a look at why this is important as a way to improve your analytical skills, which is something that because a couple minutes ago I actually made an interview where they actually do a live coding with me to say, hey, we need you to know, we need to verify if you actually know everything that you do, and if it is, well, how that works for that. So by looking at that, all right, and yeah, so by looking at that, and then because after all, coding is just a small tiny things here, especially with the, how do you put it, yeah, especially with the client directly, as a way to now understand as a way to show them if I know what I'm talking. So show, don't tell. So I show them is how can I build a particular application here in React in a simple demo using the TypeScript as a way to get this real-time feedback, and actually explain them how do I get here, how and why we are doing the things that we're doing. So that was very interesting, and this is also part of the analytical skills as well as your technical communications. So by also following is the best engineering practice, which is another important part, and develop your soft skill or non-technical communication is like be thoughtful about how you're going to communicate, be empathetic, and ultimately is the domain knowledge or the domain specific knowledge. on the language and in the computer science experience. So that was quite compelling. Okay. That was quite compelling because at the end of the day, this is what clients actually need to. Hey, I need you to improve your communicational skills, your technical communication, and your soft skill as a way to provide value to the customer, as a way to solve problems. So this course is organized like this. This is the code. This is the core structure. We're gonna walk through this and talk each one of those specific topics briefly as a way to now finally see how subclassing and extending works behind the scenes. So here is just as a way to understand why are we actually using this thing called object programming as a way to describe is how can we organize data and its functionality. People in the 60s were concerned about that, and they need to find a way of how can we actually make sense of all of this. And they come out with this approach, the object programming. Let's go to now put everything into a one object, okay, with the data and its relevant functionality, all right? And in the context of JavaScript, the way we create our object is by or using the template string, template literal, or the dot notations, the object, using object.create, or creating a function. So create an object from a function. The problem with this approach is that, especially, which is here, so the problem with this approach, where it is, okay, the problem with this approach, creating object with function, exactly. So the problem with this approach is that anytime we create a new object where their data is unique, their functionality is the same. So we are creating copies of these things that we don't need to actually to be in that object, and it's actually not memory efficient. So we need to find a way to actually get that functions, putting into some place in an object, and anytime this object that we need to create share this kind of functionality, we can have access to that. We want to create a link to that. And that's exactly what we are now doing with this solution 2 here, as a way to actually create an object that can have access to other property methods from another object, like object.create. Because object.create, what it's doing, if you take a look now at the object create here and the docs, okay, object.create, what it's looking is at the prototype, or the dunder, which holds the reference that allows you to point to an object where you can now have access to the property and methods. So look at this. The object that creates a static methods creates a new object using an existing object as the prototype of the newly created object. Even though that this might sound quite weird to hear, okay, the return value is a new object with a specified prototype objects and properties. So this is the way of how we can inherit. But I don't really like to use the word inherit, because we are now accessing to those property and methods. That's exactly what we're doing here. So below is an example of how to use the object.create to achieve classical inheritance. Exactly. So here now is using this particular approach, which is something that we're gonna see as the way of how we can now create object using the new keyword. But first, we're gonna make the object.create here for ourselves. So what we're doing here is by setting is the prototype subclass extend the superclass. If you don't set the rectangle the prototype constructor to rectangle, it will take the prototype constructor of the shape pattern. To avoid that we see, so the whole point of this is that we are now is creating an empty object in which the prototype of this new empty object will have access or will point to this, to the prototype, which is the functionality that we want to have access to. All right, so this is a sophisticated way to do this. Okay, actually you have fine control of what's going on, especially when linking things. But when it comes to now automate this particular process, which is something that now with the new keyword in ES6 and ES7 actually show you or allow you to do, is that let's go now to use is the new keyword. Okay, so now let's go now to use is the new keyword. Okay. Yeah, let's go now to use this new keyword, this feature that provide the language, where we need to actually is define objects in this way by using this or by defining this or functions like this. So when you define is your functions as a function constructor, this is where the data is going to live. Okay, and also under the prototype is where our functionality will going to live. So this is the way of how can we create now these objects using is the new keyword. And what is doing behind the scenes is something interesting, and that is well, because at the end of the day the new keyword is automating the process of linking, of allowing to have access to the other property and methods by first create this empty object on the disk. Okay, adding all of the property and methods to this newly created empty object this, and then point or update the proto, which is the dunder, the reference to the prototype function construction, where here we define is our methods under the prototype function constructor. And it's from there where you see, okay, now after that return this new object. So this new object now has the property of name and score, as well as the methods inside of the prototype increment and login. So this is interesting because now we have this way of creating objects which automizes the process of linking. Okay, is the new keyword that is actually doing that step. And this is something that you're going to see in a lot of professional code. All right, but because the designers of ECMAScript were ashamed of their inherited this prototype nature, all right, they want to make the code to look like more. Yeah, they want to make the code to look like more they want to make the code to look like more the classical object programming. And that is, for example, like Python, all right, or like C++. Like they want to look like now is using the class definitions. They want to make this look like more like a class. Okay. So, because of that, all right, Another good example is the object oriented programming here from here. As a way to look now at the classes here. What is this? Python. TOB Programming Community Index. Interesting. C. Yeah, I just wanted to show you is some. Yeah, I want to show you is you have any demo here? Interesting that you don't have any demo here. You know, prototype base, which is something that we're actually looking at. Okay. Anyway, class-based. But is this class-based programming, inheritance? That's quite interesting. Yeah, imperative programming, procedural, and functional programming. Wow, I'm amazed. Wow. I mean, I can create that, but it's like, what in the F? Let me put it here, C example. Wow, Wikipedia doesn't even show you that. But the idea is this structure. The idea is to have this structure. The idea is to have this structure. The idea is to have this structure. Okay? You might argue, wait, what the is all of this? The idea is to have this structure. What you're going to define is your public and your private property and methods that it can be quite hard to describe initially. But the idea here is that with the new keyword, it allows you to, well, somehow define is that. So the idea here is that with the solution, with the new keyword, okay, is allow you to automate that process, okay? When it comes to now handling is all of this reference, all of this linking process. So the language itself is actually taking care of that for us. So Again, as I mentioned before, because at the end of the day, people, the ECMAScript designer, were ashamed of this prototypal inheritance, and they want to look our code to be more object-oriented programming, okay, to look like classes, like Python, all right? So now they decide is to allow us to use this new keyword where we are going to define is the data and it is functionality in there. So before going that, we need to know is how this prototype work, especially when we need to define nested functionality inside of our prototype, inside of our functionality size, or inside of our functionality portion. Okay, so because now, especially if you want to define inner functionality like this and add and that kind of thing, it's like, all right, now things get interesting, because now this is now when you want to access to the proper data, it becomes quite, it's a mysterious, but it's not a mysterious at all. It's because the way how now the language works. So for example, when we want to define inner functionality like this, okay, okay, but when we want to define this inner functionality like this, okay, and if we want to make access to the current data, to the current instance, now the value of this, especially when you define inside of a function on another function, is not what you might expect. It's not that you're working with the proper data. And this is because now how this, which is a keyword that allows you to actually access to the data instance, to the data, to the relevant data, okay, is that, well, because the rule when you define your this inside of a function is that I'm gonna be whatever is on the left side when I invoke, but because here in this moment when we're using is the value of this inside of another function, nested functions, the value of this is undefined, and sometimes the value of this can be pointed to window. So because of this particularly weird behavior, or after all it's not weird at all, it's actually part of the way of how this works, but we don't understand until right now, is that, alright, it'll make much more sense to find a way of how can we now somehow grab that data and work with that properly. Apply some functionality and some transformation to that, relevant to this data. The way to do that is by saying, alright, now that now how can we make that? Before that we use things like that or this as a way to store this, the reference of this value into a that variable, but now we can use the arrow function for that. And we also use things like bind as a way to pass the proper context to that. We don't do that anymore. We use now the arrow function that say, hey, when you want to use this keyword inside of the arrow function, you're going to create is a closure. In other words, it allows you to make use of this keyword lexically, where it was written. That's the value of the keyword. And yep, that's great, completely. So on that. Okay, on that. As we move on to look at how can we solve this, when we talk about is this scope and the value of this, and how can we actually work with the relevant data with this value using a raw function and how that works behind the scenes, we also look at how now the prototype inheritance work behind the scenes. And the prototype inheritance is by, well, you will have by default some building objects, for example, like the objects, for example, like the function objects, as well as class, which is a special type of functions. Okay, but first we're starting with the object, where now it can inherit or can have access to property and methods to the prototype, similar to the function. So when you create a function, a new instance of the function, that instance, their this link, now reference is to the functions constructor instance property. All right, which in terms is actually linked to the prototype links to the object for that. So if you can see like this, if I don't lose my mind, which is, hey, let me create now a function here. Say, hey, const fun1. Yeah, const fun1. Okay. And okay. You're going to create a function here. Now we're going to these two only console log here this. Hey, function 1. Okay. So the function 1, okay, now has a link to the function constructor, okay, or the function prototype here, as I mentioned here. So now you can have access to all of these inner methods, the apply, the argument, bind, call, and that kind of thing. All right. So because of that, that prototype, which you have that this is the inner methods that this function will have access to, okay, it has also a prototype or a reference, the dunder proto dunder, that points to the objects in this case, right? That points to the objects, where now this object proto is actually holds the reference to the function, where you can have access to the property and methods from that. And inside the prototype, you can see that now this actually is linking to the object prototype. Okay, where now that links to the prototype ultimately chains that points to null. So that's now the prototype change in action. So the prototype chain here is now first pointing to, if you take a look at this, from this proto, the proto now is pointing to the function object. Okay, this is a special type of objects that you can have access to all of their property from that. So like this, like the constructor here, okay, like this proto, that you can have access to all of the property and method from the function prototype objects, okay, or internal methods. And their internal methods are like this: apply, arguments, bind, call, and to string as well. All right. So the idea of looking at this is because this is now how you can have access to all of these property and methods. And in the case of the array, okay, and in the case of the array, when you create a new array here, which is an exotic object, as they call in the spec, okay. Now this array, okay, their prototype, the way how we can access to the other property and methods, now expose you this functionality. This array instance is pointing to the function prototype there, where now that prototype, where now that object that is pointing to the prototype that holds all of these methods, inner methods, okay, it also points to the inner exactly. It also points to the object itself. That points to null. So if you come from a background like Java or like Python, and you think that it will work the same, so the inheritance will work the same for those languages as for this, you might be surprised of this prototypal inheriting nature. Remember that at the end of the day, the whole goal of looking at the object-oriented programming is to say, how can we now bind relevant data with its relevant functionality into one single bundle, okay? And how can we make them to access to the property and data when it comes to subclassing, okay? Or the inheritance. And how inheritance has been a very problematic thing, because that leads now is to develop some other patterns like delegations, patterns that Jedify and other people actually are dedicating time and energy to that. So here we go. All right, so now that we look at that brief overview of the special type of objects, the objects, that every object has a prototype. Within the prototype, or in the case of a browser implementation, they have this dunder reference to the object, okay, or to the function, or to the prototype of the object. And in the case of the function, you have a reference to the function object prototype, okay. And in the case of the array, it also is now the proto to the array functions object constructor prototype, okay. So the idea of describing this is as a way to make sense of what you're doing and how you're doing, especially when you're creating now applications using the class keyword, which is something that before I dive into that, we need to take a look now at how can we subclass, how can we do subclassing with factory functions. In other words, with functions or with objects being created with a function, factory functions. So because of that, all right, now we look at how, here this is an example of how you can create these objects with the sophisticated approach. In other words, is using is the object.create inheritance. When you first define your objects, and then you define is the functionality, and once you do that inside of the data, because this is the data, instead of your function constructor object is when you define is the link that is going to now this new object created have access to the property and methods under this object. All right. And then if you want to create now a subclassing with the if you want to create a subclassing using this object.create, well, you now create your new subclass, you define that, you run the new object with that class, then you update is the reference of this new object created from the subclass, in this case like this, the user creator. You update the reference, and one of the way to update that is by using this static method of the object built-in, the set prototype of, where it's going to now update this reference, and now you update the reference to points to the current user functionalities. All right, user functionalities, and then you're now going to make the function constructor prototype of this subclass actually points is to the actually points to the prototype, where now here is when we're going to update that prototype, the prototype of the function constructor. We're going to update that prototype to actually now point to the base class. But as you can see here, all of these manual things to do this, which there's nothing wrong with that, okay? In fact, it's actually quite interesting to do. So exactly. So because of that, all right, of now creating this particular way, and look at how manual control you have when you are subclassing from factory functions using the object.create, and then on the subclass you modify is the prototype of this as a way to point to the function constructors, and then the function constructor prototype you point that to the base class. Okay, so with the new keywords we are kind of automating that process by saying, let's go to define our function constructor, define our method. Let's first define is the function constructor. Okay. let's define is the function constructors, where we're going to define our data, and then let's go to define is the functionality under the prototype. So far so good, using the new keyword. And then when it comes to the subclassing, what we're going to do is to define is the function constructor. Okay, and instead of calling that function, what we're going to do is to call this the base class function constructor inside of this subclass, pass the relevant this value, okay, as well as the argument, and as a side effect, this will update the value of this in this new subclass, and then we're going to add the relevant data from this subclass, which is the pay user creator, which is the balance. So by doing that, now next time we're gonna is update the prototype from the function constructor base class or subclass, and update that prototype to point to the base function constructor prototype as a way to have access to that property and method from the base class. all right, and then define is our own functionality for our object here, for this subclass. Because of this approach, you are now doing is, and this is something that you're going to see in a lot of code bases, okay? Because this particular approach now involved is the because now this particular approach involved is to passing the to updating this value from the subclass function based construction, from the subclass function constructor, you are now updating is the value of this as a side effect. All right, and this is one of the finicky aspects of subclassing in object-oriented programming in JavaScript. That particular line of code here, which is something that I think that I have is here. Let me see if I actually define that. Yeah, let me see if that actually defined that. Interesting. Okay, this is the code here. Exactly. Subclassing with the new in class keyword. As you can see, this is the way how now we are indeed actually is creating is a subclass. So this particular approach feels like a hack. I mean, it's not a hack, it's part of the design, but again, it feels, you might think that this particular approach is not quite readable. I mean, you need to, of course, need the language itself, but wouldn't be a better way to actually describe this? See, okay, how can I access to the property and methods in a way that is much more readable? Because so far, you have all of this hashes of code where you need to organize that in a very specific way. So for example, here when you define your data, and when this is when you do now the reference to update is the current function subclass prototype that points to the base class function prototype. Okay, there's a way to have access to that, and in the context here of the increment balance, you get now this. You get now this. All right. Yeah, you get now this. Exactly. So here we're going to see this. It's like, would it be a better way to actually, instead of us manually creating this reference, which is there is nothing wrong about it. In fact, it is something that you want to, all right? Especially if you have much more fine control, you can know what's going on, what will happen. But because now that we know how to do this, all right? The ECMAScript designers, because they are ashamed of the object-oriented nature I mean, they are ashamed of the prototypal nature of JavaScript. They say, all right, so we would like to now the code look like more a classical style of OOP. So for example, like in language like Python, okay? We would like to now our code look like that. So we're going to create now this syntax, this construct that allows you to define is the data and it is relevant functionality in one single bundle. And when it comes, which is something that is doing here with class, okay? So, for example, if you want to create a new class, what you are essentially are building behind the scenes is just a special type of objects. So, it's going to look now at the class keyword here as a way to understand down deep what is going on. It's the class, which is a global attribute, but in JavaScript, not in HTML, class expression, okay? The class keyword can be used to define a class inside of an expression. And the class declaration here, like so, creates, the class declaration creates a binding of a new class giving a name. And when they say binding, it's the association of an identifier with a value. This is just a fancy name to say, hey, and also be descriptive about that. It's like, hey, this is an identifier. Most of the time is this. So this is the identifier, and this is the value, which is a new class. Which is, the reality is that is a new object. Classes are templates for creating objects. They encapsulate data with code to work on that data. They encapsulate relevant data and it is relevant functionality in one place. So classes in JavaScript are built on prototypes, right? Which is good. Which is good. So classes in JavaScript are built on prototype. All right. Interesting. But also have some syntax and semantic that are unique to classes. But classes in JavaScript are built on prototypes. Okay, which is the way of how you can have access to this property and methods. All right. And you may wonder, it's like, why this is important? Why do we have this a prototype change like that? Because the nature of JavaScript by default is a JavaScript by default is dynamic and does not have static type. Yeah, right? The prototypal inherited model itself is in fact more powerful than the classical one. It is, for example, fairly trivial to build a classical model on top of the prototype model, which is how classes are implemented. Why is that? Because after all, the way how you can have access, since this is now a dynamic language or a dynamic language, okay? And when they say dynamic language, is that you can is now change is the value, the type of a, you can change the value type of an identifier or a variable, okay? So we can now have perhaps some downside of this, or reassign that, but also some powerful features when it comes to actually develop a rapid prototypal, that kind of thing. In any case, because now classes are built on prototype, which is the way of how now all of this is inherited, okay? And now they mention is that although classes are widely adopted and have become a new paradigm in JavaScript, classes does not bring a new inheritance patterns. They just reusing is the prototypal nature. While class abstract most of the prototypal mechanism away, which is exactly what it's doing, abstract the most prototypal mechanism away. So for example, the creating of reference or especially the subclassing as a way to link to this new object that you're creating, which classes can have access to. Understanding how prototype works under the hood is still useful, and it will still useful. JavaScript objects are dynamic bags of properties, and I really love this term, bags of properties. Refers to as own prototype. JavaScript object have a link to a prototype object. So when trying to access a property of an object, the property will not only be sought on the object, but on the prototype of the object. The prototype of the prototype, which is this, and so on until either a property with a matching name is found or the end of the prototype chain is reached. All right. Exactly. So far, so good. So we actually understand is something that I explained before in that inheriting methods, right? It's like the JavaScript does not have methods in the form of the class-based languages. They are just functions, and functions are a special type of object. And here we go, bro. Exactly. This is subpar because each instance has its own function property. Does not have the same thing, which is redundant and unnecessary. Instead of we can move get value to the prototype of all boxes like this. So what you're doing here is to moving all of the prototype to that. That actually points to the box prototype object. Like so, okay. And we're back. Okay. And we're back. And we are back. Okay. So now, now that we know how this class works behind the scenes by looking and understanding is the prototypal inheritance, which is the vast majority of senior developers or a lot of people, they don't know how actually the class keyword is going on behind the scenes. And this is something especially important to understand, right? As you move on further and further in your career. And for example, if the ECMAScript designers decide to now add new features, now functionality to the language, you can now be aligned with them. So you can understand by looking at the spec, it'll make a lot of sense of what's going on and what are the things that they have added to the language. All right. So now that we know that, if we can see here, classes are in fact special functions, which means that functions are special type of objects, all right, where now these have this ability to be executed and to store data under the prototype. Okay, so on the class, we can have these class expressions, class declaration, all right. So where now the anatomy here, like function expressions, class expression may be anonymous and have name that's different from the variable that is assigned to. However, unlike function declaration, class declaration have the same temporal dead zone restrictions as lets or const, as behave as if they're not hosted, which is interesting. The body of a class, they are not hosted. When you say hosted, is unlike function declarations, class declarations are not hosted. Understand that. In other words, is that, or in some interpretations, hosted, but with the temporal dead zone restriction, which means you cannot use class before it was declared. In short, is that hosted. You can use this unless it's declared first. So functions, they're hosted. Okay. So functions are hosted, but class are not. So you can get yourself familiar with this as a way to understand now this a little bit more. All right. Class declarations, hosting, and class expression. Similar to functions, class declarations also have their expressions counterpart. Class expression can have name as well. The expression's names is only visible to the class body. So that's it. You know, it's like always define your class first. They're not hosted. All right, and then we can now take a look at the anatomy of the class, where this is made of the three kind of aspects. We can categorize by three kind of aspects. This is the kind, okay, which is getter, setters, method, or fields. But it is kind, all right. But it is location. Hey, it will be public or not. I mean, all right. And by location, hey, all right. This will be static or instance. All right. Hey, this getter, setter is public or these getters, setters, methods, or fields are now is are yeah, all of these getters, setters, methods, and fields, they are now statics, meaning they are in the they are now they live in the built-in objects, or they live on the instance. All right, the locations, and then the visibility, which is, hey, these getters, setters, methods, fields, are they public? Are they private? So I think this way of organizing this is quite compelling, quite interesting, especially to have clarity. And once you have that clarity, you can now have much more fine control, and you can now direct your actions. You can be more effective and effective. You can be more effective and efficient when you do a task. That's the entire reason of having clarity here. Is that by understanding how this structure works, by even also look at that, understand that, and if we need to actually summarize is those particular structures, especially the way of how now this course is organized, okay? Now it'll make much more sense to, when it comes to revisit those concepts, understanding is the storytelling thing, the storytelling part of that. Okay, cool. Now, what's next? Well, that now we have the ability to understand is the class body, and we can characterize this is by first you need to have a constructor, which is, if you remember from the new keyword, we have is this function constructor where we're going to initialize is these objects, okay, as well as the body in the body characteristic, that it can be with by their kind. This is a getter, this is a setter, this is a field, this is a method, or it can be is by location, which is, hey, this will live is on the built-in objects, or per instance, and by visibility, hey, this is public, no, this is private. All right. So you may wonder, okay, enough of me talking. All right, because we want to know is how can we now create classes. And pretty much the way we can create a class here is by, well, writing is this and say class. It's going to define is the user. This is the user creator, right? And the body, where now it must have a constructor, where this constructor is going to receive some of the parameters that are going to be used as a way to create this new instance. And the way to do that is by using is the this keyword. So there's a couple of things that is doing behind the scenes, because after all, it's using the prototypal inheritance when you run this. So it's using the this. So first, when we run this function constructor, it will say, hey, I'm gonna make the use. I'm gonna make is the this as a way to now create an empty object initially, and then add all of the property, the relevant property for that, name and score. Okay, name followed by another this, that score. Okay, and now let me link is the functionality, or in other words, is the prototype. Let me link is the proto to point to the class user creator prototype, which is where we're going to hold all of our methods defined here, like increment, okay, like increment. You can have access to this as well as a score. The value of this inside of a method refers is to the current instance. That's something interesting to know. And then you define is this score will be plus plus, okay, and I want you to now return that. No, so I do return please that. And the other will be is login. Return the here we're gonna return is this string. Say, hey, you're logging. Using the template syntax. All right, so far so good. And when we want us to create now this new user, you say, hey, user one. By using is the new keyword with the class, by calling is a class, user, user creator. Here the convention is that put all of this, the first letter as the capitalized the first letter, user creator, like so. All right. Okay, cool. Doing this, and this is cons user one, new creator, like so. Constructor increments and login, and we're going to pass here now the arguments, say Alice and 20. And then I want to now run this. So what it's gonna do here, okay, is create a new branch execution context where now it'll run the function constructor here by saying, hey, first, again, remember that the way how the class behave is by following is the prototypal inheritance, and that is, well, let me now run the function constructor here, okay. Look at their inner properties. So let me run is the constructor function here, okay, and then add this, and then create the value of this as an empty object, okay. I'm going to add all of this property as it is. Let me also is update the prototype, or the dunder to points to the prototype function constructor, and in our case is the user creator function constructor that will contain is these methods like increments and login, because behind the scenes that's exactly what is doing this new keyword as well as the class, okay, and then return that object. So now when we print this, we call method like user login or user one dot increment, okay, increment, we got is this. Interesting. If we call this user one login, hey, you're login. That's interesting. That it didn't run that. Oh, it run the last statement. Okay. Hey, you're login, and that kind of thing. So this is something interesting because when you take a look now at the ECMA script specification on the class, all right. Just take a look at the class here. That's right. The class body, the class tail. Nobody wants to. Class definitions as part of the language functions and classes, and look at the evaluation here to see what it's doing. Okay. Perform the binding class declaration evaluation, which is runtime semantic. Binding class declaration evaluation. Let's talk about it. Let's talk about it. So binding class declaration evaluation. Okay. The syntax direct operations binding class declaration evaluation takes no arguments and return either a normal completion containing a function object or an abrupt completion. A normal completion container. Oh, return is an object, the record specification, a type, the value, and the target. Normal completion record. A normal completion containing a function object or an abrupt completion. So what this is doing is to create now is a new function for ourselves. Okay, it is defined piecewise, a function object, by the way. Okay, and returns either a normal completion containing a function object or an abrupt completion. It is defined piecewise over the following productions: class, binding identifier, and class tail, or this. So let the class name be the string value of binding identifier. Let the value be class definition evaluation of class tail with argument class name and class name, which is now is going to let defining is the class name to be the string. Okay, hey, this will be the class name. Hey, this will be the value. The class definition evaluation of class tail. And this is now class definition evaluation. Here we go. The syntax directed operation class definition evaluation takes argument class binding, a string or undefined, and a class name property, property key or private name, and returns either a normal completion containing a function object or an abrupt completion. For ease of a specification, private method and accessors are included alongside private fields in the private element slot of the class instance. However, any given object has either all of null, private accessor, This feature has been designed so that implementation may choose to implement private method and accessors using a strategy which does not require tracking each method or accessor individually. For example, an implementation could directly associate instance private methods with their corresponding private name and track. For each object which class constructor have run, for each object which class constructor have run with that object as their this value, looking up at the instance private methods on the object to consistent checking on the class constructor, because it's looking at the class constructor, which defines the method that has been used or to initialize the object, then return the method associated with private names. So this is pretty much what it's doing here, you know? And it's doing a lot. And it's doing a lot of steps here. Let be the lexical environment of the running execution context. In other words, when you are now doing this, you are now running the execution context. Let M the lexical environment of the running execution context. It's actually creating a new brand execution context. Let the class M you declare that class binding if not undefined, then perform class M create immutability binding. Let outer private environment class private environment. If class body is present, then for each string dn of the private bound identify class of body do if private is class private environment. Okay, now it's constructing is the body here. If class inheritance is not present, then set the prototype of the pattern to an object prototype and let the constructor pattern be the function prototype. That's quite interesting. That's very, Very, very interesting. Because behind the scenes, what you're creating is a new object. When you're creating a new object, the object prototype portion or the proto parent will be pointing to the prototype, and the constructor parent be the function prototype. Okay. So this is now how it's actually creating is the class inheritance by default. When you're creating a new object using the class, it's saying, hey, the top of the prototype change will be the object, and then now, or in other words, is now the constructor parent. Exactly. Is that the prototype of that will be a function. So the reference of this new object created will be points to the function prototype, okay, and that prototype will point is to the object prototype. That makes a lot of sense. Okay, this is what we're creating is a new object for that. Okay, this is what we're creating a new object for on that. So far, so good. All right, cool. Cool. But what happens when we need to actually is create is a subclass. Okay, if class heritage is not present, this is what you're gonna do. Pretty straightforward. Nothing too fancy. It's actually much more cleaner. But what happens when we want to do subclassing? Set the running execution context lexical environment to the class M. No, the running execution context private environment is outer private environment when evaluating class heritage. Let superclass ref be completion evaluation of class heritage. Set the running execution context lexical environment to M. Set the running execution context. Interesting. Set the running execution context lexical environment to environment. Okay. Let the superclass be get value. If superclass is null, then prototype parent be null. The constructor parent will be function object. Okay, function prototype. If not, is constructor a superclass is false, then throw a type error. This is when when subclassing, okay, when you're doing the extend, it's saying, hey, if I get now class heritage, okay, which is part of the class tail, if I have some class heritage here, class element, exactly. Look at this. Look at what the extend is doing behind the scenes. Class heritage. Is the class heritage say is not present, then the proto parent. So if you're not present, so let me now update is the object. This new object's created proto to the function prototype, and update the function prototype to the object prototype. That actually that proto reference points to null. So far so good. All right, but what happened when we need to actually look at the class heritage? Things getting more interesting here. So if class heritage is present, which is, you may wonder, what is class heritage? Well, it's actually very, very descriptive about it. Okay. What French toast did you send me? Class heritage. If you have now the extend keyword, let me do now a couple things here. If the superclass exists, or if the superclass does not exist, I'm not going to do it. But if the superclass exists, I'm going to now do this. The base class must have a constructor function. Is constructor. The abstract operation is constructor takes argument in A.K.A language value and return a boolean. If determining if argument is a function object would construct internal methods. Exactly. Because now when you run the extend, it's gonna check exactly when you run the extend here, okay, it'll say, hey, is the base class has a constructor function? If it is, all right, good. If it's not, I'm gonna throw an error. Let me now here make the proto pattern be the get superclass prototype. The proto pattern is not an object and proto pattern is not null. Okay, if proto pattern is not an object and proto pattern is not null, throw a type error exception, which means that they must return is an object. The proto pattern must be an object, exactly, which is the constructor. The constructor must return is that. Let the constructor pattern be superclass here. This is something interesting here, because it's now with the extend, is the extend that actually is now getting is the prototype from this base class. Holy moly. Is now the extend say, hey, let me now, okay, let the constructor pattern be superclass. Let construction pattern be superclass. Let constructor pattern be superclass here. Let constructor pattern be superclass. Okay, let constructor pattern be the function prototype if the superclass does not exist, but the constructor pattern now will be the superclass. Get the abstract operation of this and returns either an ultimate completion, an A.K.A value, or throughout completion. It's used to retrieve the value of a specific property of an object. If perform the following, okay, the value specific property of an object. Okay, I'm getting is the prototype from the base class. Okay, get the superclass prototype value. Okay, and then point, oh my god, and then make this function, oh my god, and make this constructor function prototype access to that. Jesus, so when you run this, when you run the new class keyword, what it's doing behind the scenes is, especially with extend, is saying no. Okay, let me now create is the this value initially not with nothing. Okay, let me define that, not assign any value. Okay, let me now actually is run the function constructor. Okay, let me now is if there is present, let me now get the prototype from the superclass. Okay, and let the constructor pattern be superclass. and actually is, I get the value, I get the reference from the prototype, okay? And if proto pattern is not an object, and proto pattern is not null, throw a type erection. And let the proto pattern be, okay, and let the proto pattern be the prototype of the superclass. And let constructor pattern be superclass. So this is when you are now, when you initially runs this is that this is initially with empty value, all right? Then you're gonna say, all right, if that class exists and have a function constructor, okay, now let me actually get if the prototype, okay, let me get the prototype value, which contains all of their functionalities, okay, exactly, which contains all of their functionality, and let the constructor pattern be superclass. So what it's doing here is that now get me is the prototype from that. Okay, so let get me is the reference from the function constructor prototype, okay, and let the constructor pattern be superclass. Okay, let proto be ordinary object created with proto pattern. So now the current proto here will now point is to the prototype of the base class, of the super class. Oh my god. If class body is not present, let constructor be empty. Else let constructor be constructor method of class body. Set the running execution context lexical environment to class. Set the running execution context private environment to class private environment. If constructor is empty, then let default constructor be a new abstract closure. Yeah, if constructor is empty, then let default constructor be the new abstract closure with no parameter, with no parameters. Okay, if the constructor is empty, okay. But if the constructor exists, okay, define the method of the constructor with argument proto and construct pattern. Perform make class constructor and set pattern there. Make class construction. Make class construction and perform set function name. Exactly. Set function name like this. The abstract operation set function name takes arguments f and a name, an optional argument to prefix a string and return when used. It adds a name property to f. It performs the following step when called. If name is a symbol, if name is private name, if f has initial name, if prefix is present. What the fuck is it? Set function name. Okay, set function name. Set function name. Perform make constructor. Run the constructor here. What in this case is that the abstract operation make constructor takes argument f, an optional argument writable prototype, a boolean and prototype on an object, and return in use. It convert f into a constructor. It performs the following step. If f is an MScript function object, assert that this is not a constructor. and make class constructor. Perform make constructor. If class heritage is present, set the constructor kind to derive. Define method prototype. Define method property. Proto constructor false. If class body is not present, let elements be an empty list. Else let elements be the non-constructor elements. For each class element of E element, do, if static, do this. Okay, so way to set all of this static. Element is class there, class static book. Set the runtime execution context lexical environment to M. If class binding is not undefined, then perform class M initialize bindings. Set private method to the instance, set fields to the instance. For each private element, do this. And then set the running execution context with this. Holy moly. But it doesn't tell you anything related to the super keyword, or I think it is. Because this is class definition. Class field definition evaluation. Class static block. Evaluate class static block. Class elements evaluation. Class definition evaluation. Runtime semantic. Binding class declaration evaluation. Runtime semantic evaluation. So on the class elements evaluation, class definition evaluation here, what it's doing is that once you have is the extend keyword, which is something interesting, that is the responsible to actually is set the prototype of our product, set the proto under the prototype function constructor here that points to the function constructor base class prototype. Okay, like this. All right. And now let the proto of this object exactly be an ordinary object created that points to the proto pattern. Exactly. So the prototype of this object is now pointing to Let the constructor be the defined method of constructor with arguments, proto, and constructor patterns. Let the constructor info be a closure, make class constructor, and send function name. And the set function name, the abstract operation set function name takes arguments f, a function object, a name property key, and a private name, and optional arguments prefix, a string, and returns in use. It adds a name property of f. It performs the following step. It adds the name property to f, which is a function. Set function name, and it performs the following step. If name is a symbol, else if name is a private name, if f has an initial name internal slot, set f initial name to name. If prefix is present, perform define property or throw under the function object name property descriptor that will contain is this. So you are now defining as their own properties here. Okay, let constructor info be defined method of constructor with argument proto, make class constructor, and abstract operations make class constructor take arguments f, and ECMAScript function object, and return in use. It performs the following step. Is class construction in false? Set this function is class constructor to true, which is a hidden property. Okay, so oh my fucking god. It's because now it's saying, all right, now that I initialize my object here, okay, and verify, now that I initialize my object here, okay, if class body is present for each string private bounds, if class private environment.name contains a private name, else net name the new private method whose description is at the end, append name to class private environment. Where now this class private environment, okay, set the running to the class M. Okay, this is now where you're going to have the, okay, this is now the run, okay, the env, set the running execution environment, lexical environment to class M. What we're going to have is the data from that, as well as the private environment. For each string DNS of the private bound identifier, we got this. Exactly. Contain a private name pn such as pn description is this. If class inheriting is not present, then let proto pattern be object prototype construction pattern function dot prototype. And let the proto of this object here Because here first is evaluating the class body. Okay, it's evaluating if we have now a class body. Okay, first is evaluating is the class body, and if we have the class inheritance. Okay. What it's doing is the bindings here. Is to set up everything, to actually detect if there is an empty object here. Be superclass. Let the constructor pattern be superclass. What we're getting is to get the value of the prototype here. The proto be ordinary object, proto pattern, as a way to create that reference. It communicates intention to create an ordinary object and not an exotic one. So run the constructor, perform make constructor, and now the make constructor here it say if this actually is a function constructor, it's an extensible object that does not have a prototype own property. Exactly. Define, perform, define method property proto constructor. If class body is not present, let elements be a new empty list. Yeah, if class body is not present, let elements be a new empty list. Else, let elements be the non-constructor elements. And this returning is a function. Let be the active function object. Components of the running context is also called Active function object, lexical environment, variable and private environment. Let me take a look now at what he had to say.
Refers to, let's go run user creator. Just like we did before. Go run user creator. Make the. Are you ready for this? I'm ready for this. This is our final code, folks. Paid user 1 is actually getting dark. This is a very bad sign. Okay. This is our final code. We're like down to our final. This is our final execution content we're going to do tonight. Sorry. Let's pretend today. All right. Paid user 1. Let's pretend for ourselves it is still today. Called with that mutative, that powerful new keyword, call paid user creator, pass in Alyssa 8 and 25. Okay, here it goes. Big execution context. There it is. Into it we go. And the first thing, where's enough room there? Hold up. The first thing in local memory are our argument parameter combos. Let's have Michael help us out with those. We're calling page user creator. That means we run the page user creator function, which happens to now be called constructor as part of a class, but it is just a function here. And that says we're accepting paid name, paid score, account balance. So talk me through the parameter argument matching here. Beautiful. Yeah. We are now able to generate an object that does not have functions on it, and user 2 would be very similar, again with the specific data for user 2, but no functions copied on it, but they're still available. This would be it. This would be pretty nice. But we want to produce a paid user that is just like a user, but a little bit more specific. It has some bonus functions, or so it has some bonus properties, but also some bonus functions that are going to work on those bonus properties. Perfect. Let's see if we can do it. Right-hand side here, here we go. Here we go. I'm just putting this here to show we on the right-hand side. Who shall I call? David. Excellent. Help me out, David. We declare a class which is
Help me
a
out
function
here.
object combo. Give me a second while I put it on here. Name paid user creator. Hold on, paid user creator, which is a function plus an object.
Mm-hmm.
Oh, hold on. Yeah, that's extends bit. Oh shit. Okay. Now it gets interesting. I'm going to use a different color pen for everything that extends does. Okay. We ain't got many pens left at this point. Thank you, man. Shall I use our... Yeah. Oh, actually I'm going to use red. Yes, I quite like that sort of complementary to the pink for class. I use red for everything that extends is going to do. Okay, first let's just get the regular stuff. So it's a function object combo. So its function is subtitled constructor. Subtitled constructor. There it is. And it has a property on its object portion, prototype. We know this is our regular stuff.
Because after all, this class is the function.
We're going to stick what function?
And the prototype.
Increase balance. Increase balance. And that's done for us now, rather than have to manually assign it there. It's just done by putting it in the class.
Exactly, by putting in the class.
It's a function. Okay, so what does extends do? Extends user creator is going to do two major things. We want any object that comes out of running paid user creator, which will be paid user 1, we want that paid user 1 to have a bond to this set of functions. Well, that makes sense. We know that. That's going to happen by using new keyword, running paid user creator. It'll get a bond automatically to the set of functions in the proto reference. No problem. But we want that object to also have access to this set of functions. So what, when it goes looking in here for say name, do we want to happen set? When that object goes looking for say name in here, doesn't find it, we want it to go looking.
Its proto link should link up to
It's proto link.
Red means extends does it. So the first thing extends does is set that proto as a reference up to user creator.prototype. No problem. We did it manually before. .prototype. We did it manually before, if you remember.
By using
user
this
creator.prototype,
the
setting the object on the
prototype,
prototype,
exactly.
replacing the whole object and making it have a link through its proto up to
And
that
making it
user
have a
creator.
link to that,
Manually
which is object
now,
prototype.
Extends does it for us. Extends automates that for us. And the bond is made up to
the base class.
there, with the help of extends. But extends does something else. We want to, when we run page user creator with a new keyword, we want to run the constructor portion that we then want it to use the work we did earlier of assigning properties in user creator, to use that to help create the object with the right properties on it. Now remember we did that earlier? We used user creator with call and then we assigned to this. We ain't gonna need to do that anymore. Now, inside of the function, the constructor bit, that when we run page user creator, creates our object with the help of the new keyword, we're gonna run super. And super is gonna say, go run the user creator bit. It's gonna be a little bit finicky how it does it. We're gonna see in a second. The spec explains it. I've only ever seen my favorite duality explain it explicitly. Otherwise, no one else explains. Finicky how it does it. We're gonna see in a second. The spec explains it. I've only ever seen my favorite duality.
Okay. Oh. Exactly. This is how you use this class. This is how you use these classes. New, Jake's instance of person, true, Jake's instance of employee, is true. Jane.describe, return is super.describe. By calling is the super method, okay, which is person call this of title, where now this of title is a CTO, okay. Person call Jane CTO. The class are roughly equivalent of the following code: super, and has no simple equivalent. Oh my god, this is where you get this. 2015, holy, Dr. Axel Rauschmeyer. My respect, bro. Almost 10 years. Oh my god. Jesus. Oh my freaking this. Okay. The classes are roughly equivalent to the following code. Super has no simple equivalent. Okay. You define your function constructor, your superclass, as well as under the methods, the subclass for this, and here's where you create your reference with objet.create.tab. Objet.prototype. Right now you're not able to see what I'm doing. Oh my god, okay. No. I see the spec. The spec is quite confusing. The spec is quite confusing and it's not telling you all of this nasty little stuff. So go read go read duality in JavaScript. Oh my god. This came from Impatience Programmer. Jesus. Is this free? I know, of course. Holy hell. Get started quickly by initially focusing on modern features. Test-driven exercise available for most chapters. Cover all essential features of JavaScript up to including the ES 2014. Optional advanced section let you dig deeper. No prior knowledge of JavaScript required, but you should know how to program. Was previously called JavaScript for Impatience Programmer. The new names reflect it is rather larger scope, which has exceeded initial plan for a long time. I don't think this is public. What? This is public? What, motherfucker? Is this shit is public? No. What? New JavaScript? What? Is this shit is okay to actually define is all of this. First step was using JavaScript, the big picture. Structure of browsers and nodes, syntax, console interactive, assertion API, variables and variables, let con design between, and all of the terminology. Values, operators, primitive value, the non-values undefined, no booleans, conditional operator, binary logic operators, numbers, the precision of number decimal. Okay, background floating point precision, integer numbers in JavaScript, bitwise operators, math, data property, exponent, roots, logarithm, rounding, trigonometric functions, various other functions, sources, big ints, arbitrary precision integers, advanced, big ints, Unicode, a brief introduction, code points and code units, encoding, graphene, clusters, string, cheat sheet, backlashes are used, escape literal to represent this, assert or equal, converting value to strings, concatenated string, JavaScript character with scope pointer and graphenes, string methods, exactly, include, start with, end with, index of, lags, index of, splitting and joining, assert, deep equal, padding and trimming, exactly, can allow you to add some padding and trim, blank string literal, accessing JavaScript characters, string concatenation, concatenating via array.push.join, converting to a string, using template literals and tag templates, symbols, control flow, motivation, throwing and catching, motivation, throwing and catching, exceptions, then finally clause, errors in a subclass, callable values, kinds of functions, ordinary functions, specialized functions, the purpose of a class is to be a constructor function, specialized functions are still functions, the arrow function, special variable this in methods, the special variable this in methods, ordinary functions and arrow function. Kinds of callable. Okay, oh my god. Returning values from functions and methods. Parameter handling. Method column and line. Modularity. The essential of classes. Classes are basically a compact syntax for setting up a prototype change, which is explained in previous chapter. Exactly. So anytime you create an object, it creates a reference to that. Oh my god. Okay, okay. You can either read all the chapter online or you can build the full version of it. Because it reaches two classes. Holy shit. Collection, synchronous iteration. Holy moly. Iterating, manually iterating in practice. Type array, binary, data, advanced. Maps, weak max, sets. Weak set, destruction, synchronous generator. Asynchronicity. The call stack. Oh, okay. The event loop. How to avoid blocking the JavaScript process. Padding of delivering asynchronous. And resources. Promise for asynchronous programming, the basis of using promise. Holy moly. So we can tenables, exactly. Tips for chaining promises. Promise and asynchronous programming, async functions. Async functions, the basics. Returning from async functions, a way working with promise. Async functions, the basic. Returning from async functions, a way working with promise. Concurrency and await. Alright. We don't need a wait for fire and forget. Concurrency and await. Tips for using async functions. Concurrency and await. Basic asynchronous iteration, synchronous generators. Async iteration over node streams. Example of chunks of line. So anytime you call this by passing as a chunk iterable, holy moly, more standard library, regular expression, dates, creating a parsing in JSON. Holy moly, bro. Holy moly, bro. All right. Some advanced language features are not even explained. Theory and techniques. Composing regular expression via rect. Metaprogramming with proxies. Why you lower that? No. Okay. Jesus, my God. Shell scripting with no. Tackling TypeScript upgrading from JavaScript. Exploring ES6. Holy moly. Exploring Reason ML and functional programming. Oh, but this is by Facebook. Holy moly. The details. Class declaration, class expression, class tail, heritage, body, and all of that. Observation. Similar to functions, they're both class declaration and class expression. Various checks and features. Runtime. This method cannot be used as constructor. And the extending. Rule for extending. Don't extend class foo. Okay. Yeah, it's like looking at the spec is something that is quite profoundly painful. I mean, get used to the language, but you can do that progressively, so no problem about that. So the details. Oh, this block is updated. Okay. C prototype.m. Extend the null class for extend null. The prototype foo is the function prototype. Okay. Oh my god. Okay. Okay. That's actually a very interesting source. That's actually a very, very interesting source. Duality. That's right. Duality here. Duality blog about classes. Holy moly, nigga. Jesus. So this is where all of the things come from. Jesus. ECMAScript proposal set methods, iterator helpers. 2022. Damn son, 2022, bro. And iterators helpers. Oh my god. Alright. Okay. Cool. Let me see. Okay. I think we can at least dedicate half an hour to this.
Explain it explicitly. Otherwise, no one else explains. The super is going to go and take us over to the user creator.
The super, you're going to take us over to the user
creator.
function
to create our object. And by the way, unlike the super is going to go and take us over to the user creator and run its function to create our object. And by the way, unlike here, where we made the object inside page user creator and then we mutated it one layer out, we're actually going to make the object, wait for this, we're going to make the object inside a user creator. But it's going to have its proto auto set to page user creator's functions. We'll see in a second. But that means there's one other thing that extends does. I'm not sure if you can tell this. Okay, it does this.
It's also because it's also
it sets page user creator, the function, its proto
it's proto
to
the function constructor.
The user creator function object combo. To user creator. Let me just extend this down a bit here. No, please, don't all laugh at once at my... Okay, let's extend that down slightly. The second thing it does is we have another property on page user creator, proto, that normally would just link to function.prototype, where all the shared, anything the function has access to will be. This is the moment we go, and just give up. But it links up to user creator. We're going to see what this is going to let us do, people, is that when we run page user creator, the function, it's going to create us an object inside. We're going to call super, and that super is going to go, what am I? What do I need to go and run? It's going to go look at proto, see user creator, and go and run it. Create our object. Promise one for a second, Seth. I want to dive into this piece.
Okay, I kind of want to extend on this piece a little bit. So if you left off constructor on page user creator, it's going to look in proto for constructor and just run constructor directly.
That's a different factor. If you leave off constructor, it's going to automatically put in a very simple
page user creator. It's going to look in proto for constructor and just run constructor directly.
That's a different factor. If you leave off constructor, proto, see user creator, and go and run it. Create our object. Promise one for a second, Seth. I want to dive into this piece.
Okay, I kind of want to extend on this piece a little bit. So if you left off constructor on page user creator, it's going to look in proto for constructor and just run constructor directly. I kind of want to extend on this piece a little bit. So if you left off constructor on page creator, it's going to look in proto for constructor and just run constructor directly.
That's a different factor. If you leave off constructor, it's going to automatically put in a very simple constructor that returns an object. So look, oh my god, look at what they call it a subclass, right? So, not a base class, but a subclass. Look at what it has on it. That was just from and everything in red was added by extends. One portion ensures that the objects that come out of running this function have access to these functions. That's what the prototype.
Exactly. Under the prototype. Exactly.
The other portion, the other consequence of extends, ensures that the super, which when we run page user creator, we're going to run, makes us go and run user creator to make the object there. And that is stored, or that link is stored, which when we run proto bit on the function collection of functions, it ensures. The other portion, the other consequence of extends, ensures that the super, which when we run page user creator,
ensures the super
makes us go and run user creator,
have the reference to the user
to make the
creator.
object there. And
Have
that
the
is stored,
reference
that link
to
is
the,
stored in
yeah,
proto.
oh my
That
god.
is where it's stored. If you overwrite proto, then the super goes, I'm not there anymore. When you call super inside of that, it is absolutely heading to proto and going to look up here. If you overwrite it with
Let's let's get into it. Let's put up let's test this, bro. Let's test this. Let's test this. Okay, because at the end of the day, okay, we want us to put a practice is at the class keyword, not to create a new object, which is something that we are know what it's doing behind the scenes. Let's say user creator for this game. Okay, we're going not to define like this. Is with this shape, is in this form. Well, here we're going to define is the constructor here. We're going to take in the name as well as the score, and inside of this, we're going now is to okay. Inside of this, we're gonna now is do this. Hey, I want you to now, when I run the new keyword using the class way of creating objects, I want you to now actually create this object for me. But because this object initially doesn't have any, it doesn't extend anything, it's just a plain object. Like so, what the fuck, React DevTool? Why do I have access to this? It's like, oh, is this actually made of React? Alright, say no more, bro. Okay, that's oops. I access to those property and method. You know, the value of window this is now showing is that, hey, you know what, you can access to this property and method here of this new object that you are creating here inside of the constructor. That's quite dangerous. Anyway, but this name followed by the this dot score equals score here, all right, and then first, when we run the new class keyword with the class, we are now running as a function constructor, okay, and first is defining is the value of this as an empty object, adding all of these property and methods to this, which is in our case the name and the scores, okay, and now creates the link because after all this class is a function constructor, is the way of how we can do this way of creating objects in using the new keywords with the prototype. So whatever we define on the body here as a method, it will be now added to the prototype for us. So for example, we say, hey, login, you know, don't we have that already created? There you got it, exactly. For example, this, it say, hey, you have now increment and logging, and these two functions will now live inside of the prototype of this function object called class user creator, which now the identifier or the variable here is user1. So far so good. Awesome. So what happened when we want now to extend, or we have to access, we want to have access to other property and methods? Glad you asked. If you don't do that, no problem. Help me out here. So we're gonna to create is another class, which is the user paid creator, that you're going to follow this thing here. So base class here should not have any constructor method, especially if they want to inherit property. Oh, in this case, I'm wrong. Okay, yes. They must have also is a constructor function here. What you're going to receive is the name, the property that we're going to now pass to the base class, name, score, and balance. And as you can see here, this is not a particularly good approach, especially when you want to create objects. We don't actually passing all of this data from the scratch. Okay, but we can say this class user pay creator, where now here we're gonna call this the super. But wait a second, the extend keyword, what it's doing is to not only update is the prototype, so it's not only update is the prototype of this function object called class, all right? To update the prototype to points to the base function constructor prototype, which is in our case to points to the methods here, to this object here, to points to the object here, to the increment and the login, but also it's gonna do now to it's gonna make the proto of the user pay creator of this subclass points to the okay, no.
No, that super ain't going to do anything to make the object there. Objects that come out of running this function have access to these functions. That's what the proto bit on the function collection of functions ensures. The other portion, the other consequence of extends, ensures that the super, which when we run page user creator, we're going to run, makes us go and run user creator to make the object there.
Okay. So what it's doing here is this. So with super, okay, which is now calling is, which now the extend, what it's doing is that, hey, I want now to set the proto, okay, I'm going to set is the proto of this class, which is the user page creator. After all, it's a function object combo. And I'm going to point that to the user creator function constructor as a way to get that object, okay? Okay, as a way to get that object. And another consequence that it's doing here is that I go now to point, when I go now to update the prototype of the user page creator property, okay, to the base function constructor prototype, which is increments and login. Holy moly. So if we say things like increment balance, for example, which is a method, and the only thing we want to do here is this. All right. This the balance, which is a property that we haven't defined. Okay, and after that I want you to return this, which is, oh my god, no, what is it? No, help. Which is now passes the name and the score to this super class. And then add this property balance to this new class balance here. Super is only valid in the derived class constructor. Oh, of course. Because I didn't specify to which one is user creator. Let me actually define this as it is. And also, in my class here, let me in fact do this. This is the asset method React. No, this is nope. It's not one. Is this one? No, I don't care about this. Oh, okay. I need to create. Interesting. Interesting. So let me not do this hard part, but in fact, is the object-oriented programming, JavaScript. Of course, because I want to create is this, right? Make there. Getting here. Hard parts OP JavaScript. There you got it. And actually get access to this. Okay. Let me close that. And in fact, you're gonna do is this here. There you got it. And this and yep. There you go. Okay, so here I'm going to create now touch class GSS. Exactly. Say class CSS example, which is this, followed by this. Okay. And oh my god, no. Well, return on investment is field search. All right. Yeah. Mother Nature claim this. Mother Nature claim my guts. Mother Nature reclaim my guts. Yep. Mother Nature reclaim my guts for a second. So this is the way of how you can create a class. You know. So this is now class, a new class, exactly, new class, or creating a new class, special type of function. It's a special type of function. All right. And now here we are creating is, all right, is the creating a subclass. What we can say is, yeah, creating a subclass using extend and super. So let me actually here create is on my GitHub is this one. Okay. Okay. Readme, that's right. There's a way to create now a readme here. So readme.md. This is the hard part of object-oriented programming here. Now my personal notes, which would be this. And then record learning process. The record learning process is like this. Okay, where it is? Where is it? Where is it? Is this point to? No, this is not point to. Okay, but How's it going, everyone? Okay, we're getting started here again. In today's video, we're going to talk about now of how class works behind the scenes. This new keyword. Okay. Is this actually pointing to that? There you go. There you go. Okay. That's it. This is it. This is it. Yep, this is it. So to create now here, repository here. Actually, it will be renamed with the async instead of the async to that. Really? Yep. All right. Make it public. Nothing. Let me actually, in fact, push to an existing repository like this. All right. It say, hey, this is not a, okay. Get in it. Try. Because we don't have any branch here. Get status is get at everything. Okay. Get at this everything, and then push that as it is. Oh, because we need to make a commit. Commit with a message. A commit with a message, which is this. The git commit remote branch, and then you got it. Error sort respect add the class example. Yep, this is it. Now you can just push this command, but we already pushed that, so we can now have access to this, and there you got it. All right, so that'll be all for this video. Take care. Bye bye.